In our daily life, we're used to thinking of space and time as two completely different and unrelated things, as well as entities that are absolute or independent of the relative velocity of an observer. Space is where things happen and has three basic dimensions, whereas time is when things happen and has one basic dimension. However, Albert Einstein's special theory of relativity says otherwise. He explained that time and space are perceived personally by different observers, and that when and where are really just part of the same question. What he realized was that three-dimensional space and one-dimensional time really just comprise four-dimensional space-time. But why tell people that the way they comprehend spatial dimensions and time is not only completely wrong, but the correct way to imagine these things is something four-dimensional and completely unimaginable, even with those crazy 4D rides? Well, the answer to this lies in relativity's consequences. What you see as just space might be seen as a mixture of space and time by me. Let's take a look at an example.
Say, we have a barn with both of its doors open. You measure a pole to be exactly as long as it. A pole vaulter carries the pole from its center now and begins to run through it. You'd think that the front of the pole would exit the barn at the same time as the back entering, since their lengths are the same. But what if we switch to the vaulter's reference frame? He is moving towards the end of the barn and thus towards event B, and we'll see event B occur before event A. So he'll observe the barn to be shorter than the pole.
But you measured them to be of the same length, so who is wrong? Well, the answer is none of you. After all, you were probably on Earth while you measured it, and thus moving relative to the Sun. And you would have seen it as only a spatial difference between the two events, while the Volter saw it as a mixture of both space and time. So time dilation, event perception, and length contraction are really just three sides of the same weird-looking coin. Now that we know that space and time aren't absolute, but are relative, then what is absolute? For starters, the speed of light is always measured to be 299,792,458 kilometers per second, regardless of the speed of the source or the speed of the observer. But the importance of space-time is shown by the fact that the space-time interval is the other absolute value. This is essentially the distance between two events in the four-dimensional continuum of space-time.
Now, if we looked at the formulae, you would have noticed that they're almost identical to the Pythagorean theorem, except for the difference in signs that tells although space and time are related, they're not the same. But the Pythagorean theorem needs the same units for both values. How do we convert space to seconds or time to meters? If you think about it, it's nothing we haven't done. It's often said that a flight to London from Singapore takes 13.5 hours. All we need to do is switch the relative speed of a plane with the universally constant speed of light, and there we go. Plug that into the speed equation, and we now have time in light meters and distance in light seconds.
And with this understanding of space-time, you can now correctly understand our universe.